Welcome to the Jack and Jake Talk, where we talk about science, theories, and all the above. I'm Jake.
I'm Jack.
And today we're talking about the planet Jupiter. Jack, what do you know about Jupiter?
I know quite a bit, actually, Jake. I studied physics in college, and astronomy and astrophysics is a pretty substantial part of the curriculum. So anything astronomy, I tend to geek out about it. What about you,
Well, I
Jake?
don't know as much, so I might go to your form of expertise. Because of the bare things that I know about it is that it's the largest planet in our solar system, and I believe it has, you're going to correct me, I know what, 9 moons? Or is it more than?
It's more than that.
Okay.
So there's four primary moons, and then there are over 90 smaller moons around Jupiter.
Okay, so I'm really wrong. Maybe I was thinking the 9 number.
Good guess.
Yeah. And I know too, even with how much they're constantly finding out more things about Jupiter. Isn't it that because Europa is one of the moons, right? One of the main.
Yes. Yeah.
Yeah.
Yeah, Europa, Io, Titan, and Ganymede, I think, are the four Galilean moons. And they're called Galilean moons because Galileo, the famous astronomer from the 1600s, was the first to discover them with his telescopes.
It's kind of crazy to think that far back, someone like Galileo was able to look that far in and be like, well, that looks like a rock in space. And then kind of identify and come up with that, right? That far back.
It doesn't take that much. I mean,
Yeah.
the specifications for his telescopes, I mean, I'm not sure of the details, but these were largely just your classic handheld, 2 lens telescope, probably no more than 5 or 10 times magnification at best. But I mean, that's enough. I mean, you can do this in your own backyard. Just take a small pair of binoculars and look up at Jupiter in the nighttime, and you should be able to see, Jupiter, which looks like a very bright star in the night sky. If you have good binoculars, you might be able to tell it has a little bit of dimension. It's not just a point of light; it's a circle. And then if you look closely enough, you should be able to see through, low power binoculars or telescope, 3, if not 4, smaller pinpricks of light that all spread out in a line around Jupiter. And what Galileo did was he just tracked the motion of those moons every night and saw that they changed position over time. And from our perspective, it's just a line of points, and they kind of oscillate, across in a straight line this way. But you can imagine, if we just turned the picture around, it would be the same as something orbiting in a circle, just from the edge on view. So that's how he made the deduction. Those are actually moons, their bodies orbiting another planet.
Dude had brains. To figure that out on his own and kind of following that. But I mean, at this during the time as well. I mean, it wasn't, I guess, not the only one that was looking up in the stars. But yeah. And then I also know the only other piece that I know Jupiter wise is about. Is it called the Red Eye? No, the Red Storm.
Oh, you're so close.
Look how terrible I am, man. If I'm so, yeah.
You're so
It's gonna
close.
kill me when you tell me.
It's the Great Red Spot.
Great Red Spot. There you go.
Yeah.
Which isn't it a storm system that's just constant on the surface? Or I guess
it is, yeah. So it is a type of atmospheric cyclone, a storm of sorts, up in the atmosphere of Jupiter. Not unlike a tropical cyclone or a hurricane that we would get here on Earth. And the Great Red Spot is the most prominent one that we can see on the surface. If you compare it size-wise, the diameter of the storm is actually slightly wider across than the diameter of the Earth. That's how large this storm is, and that's how large Jupiter is. And yeah, the storm, it's called the Great Red Spot because it looks very red and prominent on the surface of the planet. Most of it looks kind of grayish and orangish with these bands of cloud layers, but the spot sticks out pretty prominently, and it's been there for, I think, at least 300 years since we've begun observing it. I think it appeared about 300 years ago, and it's been pretty stable since then. And it's not the only one, but it's the largest one.
The largest one, because even a lot of the I do know also that a large of the amount of the surface area of Jupiter, I know there's hypotheses and considerations of if there is a true solid I guess ground of it, right? Because we see a lot of just like the storm systems that are circulating it. Just to tell you how much I know about the planets as well. Do we know, is there a surface to it, or is it just a gas?
So that is one of the mysteries. There's a lot of mysteries surrounding those outer solar system planets, and one of them is, are they just big balls of gas, or is there some kind of rocky or icy core underneath all those gas layers? We can guess. You can make some very easy deductions just based on the orbital period and the distance the planets are from the center, the solar system center, the sun, right? If you know how far out it is in its orbit and how long it takes to orbit, you can work out the approximate mass of that planet. So we know the mass and we know the size, so we can work out the density and figure out, okay, well, if it's this big and it's this heavy, it's probably made out of this stuff. But the problem is it's probably made out of a lot of different materials. So yeah, it's a big question mark. Well, what we do know, I guess, also is that it's whatever's down in the surface of the core, because it's such a large planet, there's a lot of gravity crushing down. It's very, very hot, whatever it is. It's certainly molten or gaseous, like a fusion of elements at really high temperatures. Yeah.
And it's also that thing too of, do we want to create something that we can shoot right at the planet and hope that it would survive impact to give us enough data information, right? To be like, oh, well, it got fried, partway through, the surface, and then we couldn't figure it. I guess not the surface, through the atmosphere. And then it's like, well, we just spent millions of dollars to get something fried off on the but that would be interesting to see as well, as you said, where there's so much pressure associated with it. I mean, there must be some type of surface area where maybe it causes all that storm systems or reactions to happen on the surface. Maybe it's just that a majority of the atmosphere of it is weather and has a very dense core that we just obviously aren't able to observe.
That's what we think, is it's largely hydrogen and helium, just like the sun. And yeah, if there is a core, it's very, very small and very, very deep down. And yeah, even if it is just mostly hydrogen and helium, even in the core, it's so dense, it's so compacted, it's probably, you could essentially say it's a solid, even if it's, material that we usually think of as a gaseous element. So, yeah.
And we probably won't be able to um, get any of that out if we were able to land anything on it. Maybe
Probably not. Probably not. It's probably highly toxic and highly
yeah.
hospitable. I mean, actually, now that we're talking about this, I recall that one of the theories is that the core is mostly hydrogen, but because it's so compacted, so dense, this hydrogen actually forms a metallic state. And so it's hydrogen. It is typically a gas, but it has metallic, like the solid metal properties, because of the pressure and temperature that it's under.
Definitely something that you'd want, if you observed it, you'd want to have a suit on.
Yeah, yeah. Actually, I'm glad you brought up the thought of sending a probe there, because we have sent a few probes
Okay.
to the outer solar system, and the latest one to go to Jupiter was called the Juno mission, and this was a probe. It orbited Jupiter for a good period of time, observing many of the moons and the planet itself. And I think this was in 2021 was when the mission ended. And to wrap up the mission, the spacecraft essentially ran out of fuel to maneuver, and so they sent it in an orbit where it would eventually fall into the planet. And they kept recording data as long as they could until it stopped sending data. And what happened was, this probe descended several miles into what we consider the start of the atmosphere of Jupiter. And eventually the signal was lost because the pressure started to build and it became too great. And it essentially, knocked out the spacecraft.
Hmm.
But we got a
Wow.
lot of good data from that. We learned a
Yeah.
lot about those first, few miles of atmosphere. So it kind of gave us a more three-dimensional idea of what Jupiter is like.
And also as well with, and I can imagine that, I mean, of the little that I had found out as well with the different moons and all, we've sent devices and things like that to the moons as well. What do you think are the most interesting moons on Jupiter? Because I know there's a lot of variety of all the different types.
Ooh, that's really hard. They're all so different.
Yeah.
I'm trying to remember some of the details. Some of them are ice moons.
Mhm.
It would literally be like the planet Hoth in Star Wars that you'd think of. It's nothing but a sheet of ice, bitter cold temperatures. There are other moons that are actually volcanic, and so Jupiter and the moons around it, they gravitationally interact with each other. And Jupiter's so large, and some of these moons are so close in that the gravity is very strong. And it actually pushes and pulls and warps the shape of the planet or the moon ever so slightly. And it's enough that you have, these tectonic forces, kind of like we have on Earth, but sometimes to a larger degree. So some of these planets, they actually have volcanism going on. They have volcanoes and other geologic activity like active on the planet. Some of them, they have geologic activity like that, but instead of being like that, what we think of as very hot,
Yeah.
magma, lava, these rocks that are molten. Um, the moon is an ice ball basically. So what you get is these ice like glacial flows and geysers, and the geysers will shoot ice crystals like miles and miles up into space. Actually, that was another thing with Juno. I think Juno actually flew close to one of those icy moons and collected data from one of the geysers.
Mhm.
Yeah.
Kind of makes you think of like even with our planet, like places like Yellowstone, right? Where instead of the water that's spewing it, it's ice, right?
Yeah.
And that's kind of wild to think of something like that. But also too, with that many, with the hydrogen and other elements that are um, going on around Jupiter, those planets are going to be pretty volatile and have a lot of stuff going on. Um, Now, I don't know the truth behind this one. There was some piece that I found of information saying that one of the moons could be totally diamond encrusted or some part of the interior.
I heard about that, but I don't know the details.
Yeah, maybe it was one of those things where they had found the possibility of some type of surface area being similar to diamonds, right? Because you think of all that pressure that's going on, right? And even as you brought up the fact that the gravity and such of some of those moons being so close, that's going to create some of that possibility of creating harder surfaces like that. So maybe it was just the fact that they thought that the surface area was similar to diamonds. And then someone's just like, well, so that means diamonds, right? It's a rock that's going to be shiny. It's like, so maybe that was kind of part of that where they found that there was the likelihood of there being a surface like that. And then turns out, watch, they would go to that surface area and find out that, oh, you actually probably don't want to be on that planet because to create diamonds creates an immense amount of pressure, right? If people didn't know that already about diamonds. Yeah, but I mean, also know like pop culture wise, too, Jupiter's in a lot of different pieces. I know there's a film that came out. I don't know if it was in early 2000s, mid 2000, 2010, something like that. Or no, maybe it was later than that. It was Jupiter Ascending. It was a fantasy kind of film. But I know besides that, it's also in a lot of as I said, pop culture and kind of pieces like that. But it kind of like even the fact that as we're finding out more and more about it, I mean, it's not just the largest planet, all the kind of different intricacies that go with it.
Yeah, there's so much to cover with it. I mean, even the pop culture too. I wanted to mention there's the Stanley Kubrick film, the classic 2001: A Space Odyssey.
Yeah.
One of the sequels to that, there's the book series and the movie series, is 2010 is I think the second story. And in that one, actually, there's a joint pair of astronauts and cosmonauts that go to Jupiter. And I think they tried to rescue or recover the spaceship that had been sent in the first movie and was lost because of the HAL 9000 computer that went haywire. Um, it's a long, convoluted story, but I thought 2/3 of the way through the movie, there's a really interesting part. So there's some kind of alien species that's in the solar system, but they're not showing themselves. And somehow they teleport like millions and billions of those black obelisks from the first movie. If you remember that scene with the gorillas, there's the big black obelisk in the desert.
Maybe.
But the big black obelisk is what sets civilization in motion, because the precursor to humans were like, oh, this thing is huge. What is this? Anyway, they send billions and billions of these things into Jupiter, and they fall into Jupiter. And the added mass actually crushes Jupiter down. Like the gravity becomes so intense that the planet collapses in on itself. And because it's just mostly hydrogen and helium, it starts fusion and becomes a mini star, a little dwarf star in the solar system.
Huh.
Yeah.
So note to everyone, don't send a bunch of stuff into Jupiter because there's the likelihood that it can turn into a dwarf star.
Yeah, it's a very interesting movie. I mean, that's obviously a little bit
A bit
convoluted.
out there, but there is some science and fact to it, right?
Yeah, some of the science is behind it, and I mean, it does speak to some true science with our study of the solar system and how solar systems form. I mean, it's thought that Jupiter is like a proto dwarf star almost.
Hmm.
We see many of these dwarf stars out in the galaxy, and you know, the brown dwarfs or red dwarfs, or white dwarfs, and they're very small stars, and some of them are remnants after a supernova. But some of them we think are just they're kind of like um, stars that didn't quite make the cut almost. So you have a lot of these binaries or quad star systems, and some of them just have these very tiny stars where most of the mass went to the big star. Some of the mass went to a little star, but it didn't really get started. So, like Jupiter might be one of those where it just didn't accumulate enough gas to become its own star.
So it's just sitting there in space, making a bunch of storms, fussing about it.
Good point, yeah, but it's an interesting point.
But that, I mean, that's a poor way of looking at it. But it's yeah, yeah.
So
Um,
puny maybe in the sense of a star, but enormous in the sense of a planet.
right, right. And even too, I mean, we only can conceptually look at some things like that. Unfortunately, we don't live not even thousands or tens of thousands of years to kind of see the truth of it, right? Like with some of those pieces for our observations that we can look at space, right? To see if the fact behind this. But there is, as you brought up, there's enough conclusive evidence of things like this. It'd just be interesting in I don't know, 10,000, 100,000 years, right? If it's still making its storm systems looking similar, or if there's some dramatic change that goes on, right? Um, but unfortunately, we don't live that long.
It would be very interesting to see. Yeah. While we're on that subject, why don't I share real quick? We have a few good photos of Jupiter and those storm systems. Let's see here if I can find it. It's actually sharing the screen.
Yeah, it's taken. It's just it's thinking.
I should correct the record too. The four Galilean moons are Ganymede, Callisto, Io, and Europa.
So Titan's not one of those.
No, Titan might be around Saturn. I'm not sure.
Saturn. Okay. I know of what. Yeah, one that had a. Yeah.
But I forgot to mention this. Ganymede is the largest, and it's the largest moon in the solar system, and it's actually bigger than the planet Mercury and the planet Pluto.
Hmm. Call Pluto a planet. Yay, Jack.
Yeah. What do they call it now? A dwarf planet or a
I think they
subplanet?
call it a dwarf planet. Now, Jack, you might have to try reloading. Whoa, that's trippy.
That's not what we want.
Yeah, let's just give it another shot.
Okay, here we go.
Yeah, they need to bring Pluto back. Here we go. Now I'm seeing something.
All right. So here are those Galilean moons I was talking about.
Yeah, Callisto looks pretty cool looking though. But those looks like, is that just crater wise? That's all over the planet. Um,
Yeah, so Ganymede and Callisto, I mean, Ganymede, you can see in that photo, almost looks like our moon.
Mhm.
And those planets are very dead, I guess you could say. They're very rocky and inactive. So any kind of collisions they have, the crater just kind of sticks around forever.
Mhm.
You can see Io there, the third one. It's a volcanic world, and so actually it's very dynamic. Its surface. I forget which one it is as well, Jake. But there's a few moons. There's at least one moon with the liquid methane oceans on the surface, if you can
Sounds like
imagine.
a great place to take a dip.
I know. I was
Watch, that
going.
would be the catch of when they if we eventually settled near that area. Oh, did you put on your spacesuit and took a dip in the
Yeah, so NASA's got some great web pages for all the planets, but
Yeah.
Jupiter's has a good one. It's got this interactive kind of 3D view.
Mhm.
So here's your great red spot right here, and you can see all those bands of cloud layers. And they travel cross directionally. So some of these bands travel, I guess you'd say, east to west, and
Mhm.
some travel west to east.
Hmm.
And they actually travel very fast. I think the rotational speed of the bands is about 10 hours for a one cycle. And
Yeah.
you can imagine. I mean, the planet is much larger than Earth, so you can imagine the wind speeds there. Um, you can see also here's more of those vortex storms at the
Yeah.
poles as well.
Huh. It's kind of wild to think I'm into wind patterns and all that goes along with that. And why it does move in that direction.
There's a lot of interesting science about those cyclones.
Mhm.
They've actually found, Jake, that at the North Pole, there are 8 of these vortex storms, and they're all kind of largely stationary. They stay in place.
Hmm.
Their position and size is relatively stable. Um, they tend to try to move outward, but the storms on the further out or further down from the pole kind of
Fix in the area that they're at, right?
keep them boxed in. Yeah. On the other pole, there's 5 storms actually, and they stay in place.
Huh.
There's a really nice view. Um, where is it?
That's really
There's the 5.
that's just wild though. I mean, huh.
Yeah, nature does some really strange things. So Jupiter's cousin Saturn, actually at its pole,
Mm.
it has a polygon shape. You see that?
That's huh.
It's a hexagon.
Yeah.
And actually, it's very strange. I mean, you think about these kind of normal or geometric shapes, and we think, oh, that can't be natural. But they've actually managed to reproduce this in the laboratory in a circular vat of fluid. If you
Hmm.
rotate fluid in a circular motion like you would on the surface of a globe. If you get the fluid properties just right, the speed, the mixture, the temperature, and the pressure, you can get these kind of stable patterns to form.
And probably when the planet's origin started, whenever those gases or such began, it probably kept it at that motion. It's been continual since it began.
Yeah, they stay
Wow.
for a long time.
But even just seeing that's kind of remarkable seeing the poles of Jupiter and seeing that it almost looks like opals that you would see. Um, that's a great picture, though.
Yeah, it's not photos from the solar system or from the outer space are kind of funny. So it's not a like this was probably from the Juno spacecraft, and it's not like I took a photo, snap, and sent it back, and that's the photo. Usually they're pretty heavily modified. I mean, it's still a real photo, but it's quote unquote enhanced in various ways um, to make things stand out. So like this one, if I read correctly, it should be a visible light spectrum photo. So this is sort of how it would look if you were there.
Mhm.
But the color contrast is enhanced somewhat to get these structures more prominent. And a lot of them are, I forget if the word is stereographic or composite. So this is likely maybe 3 or 4 photos put together just to get the complete picture.
Layered it so you can probably see a lot of detail that you wouldn't see with just a regular snapshot, right?
Yeah. This one might actually be one photo, but like some of these with the vortices, like you can see they stitch
Layered,
together a few different photos. Yeah.
yeah. Just had to crush me a little bit, Jack.
Yeah, but yeah, I mean, this is pretty much this is
I
pretty
mean,
much as close as it gets to a snapshot photo, and
yeah, yeah.
it's incredible. Yeah.
Yep. And I mean, and it's not like we don't enhance photos anyway, so that you can see a little bit of more detail. Um, if anyone out there didn't know that a lot of pictures have something called Photoshop related to it to make it look a little bit better than the true image. But yeah,
I will say though, I mean, Jupiter is one of those stunning planets where you can look at it through just a simple 10 times power telescope, and you'll be able to see those cloud layers and those bands, and you'll be able to see the contrast. I mean, it won't be as incredible contrasting colors as you see on the left here. This is an infrared shot,
yeah.
but I mean, it will more or less look like what you see on the right here. You'll be able to see these bands and maybe even some detail inside.
And it's even wild too, because as you had said, the movement of those storms, right? Um, are you also you be able to see at least? I mean, if you had with a 10 times full type of lens on there, you probably wouldn't be able to see much movement. But you had a much closer telescope to look in, you could probably see the movement of the storms, right?
Yeah, you'd have to take a time lapse
Okay.
because it would it's kind of like looking at clouds from a distance. They don't move much, but if
Yeah.
you wait 30 seconds till it moved, wait another 30 seconds.
Yeah.
Let's see if I can find one just to see.
Because I think I've seen somewhere. It almost looks like it quite literally looks like sand going across the surface area.
Yeah, it's pretty amazing.
That's
I mean, you can see they're moving at different speeds
yeah.
and in different directions too.
Huh. Wild, and then I feel like every year as well, we're finding out more and more about it. It's not just a um, present day stuff. And even with the Webb telescope getting sent off, and I know that's more to visually see things much further out, but probably added much more detail on even our current our solar system.
Yeah, it's really exciting. I mean, it's easy to forget that there's a lot we don't know about. It's easy to think, okay, it's all settled science, and you know what there's not much left to know. But
Mhm.
in reality, there's so much we don't know, and Jupiter is a great example of that. I guess to maybe to end, let me share one other photo. This one is from the James Webb Telescope, Jake, of Jupiter. This is a great one because it kind of highlights another phenomenon,
Okay.
which is the auroras that are at the poles of Jupiter.
Huh.
Planet gets very similar aurora behavior that the Earth does due to its extremely strong magnetic field. The field's actually uh, varies between 20 and 50 times stronger than the magnetic field that Earth generates. So you get these stunning auroras.
It's wild, man. Huh. Cool, cool. Well, I know you you definitely covered much more about the planet Jupiter than I knew, not even knowing the name of the correct titles of different things. But I think that about does it.
Next week, it's all you, Jake. It's all you.
we both have our backgrounds, right? We both know different things, and that's why on this, this channel, we're talking about it, learning a little bit more, and hopefully people listening learn a little bit more about things as well. Thanks everyone for tuning in and listening about Jupiter. Jack, what are we talking about next time?
Next time, Jake, we're going to talk about microclimates.
That's going to be a fun one. It's going to be really interesting. All right. Thanks again, everyone, for listening, and hope you listen to us next time.